So, good afternoon. Thank you for joining us here today. As we go through, if you have any questions, go ahead and send them in using the chat as part of the Zoom interface. I'll go ahead and get started today. So, we're talking about our Wi-Fi 7 access points. So, Wi-Fi 7 is still a somewhat new technology, so I will have a few slides talking about Wi-Fi 7, just a few. But we've been, adding new Wi-Fi 7 APs, nearly one every month this year. So things have finally settled down. We've fully launched our Wi-Fi 7 lineup. So I thought it'd be a good time to go through it and explain the different models that we have and help you try to figure out which ones you may need for your applications. So to start with, technology-wise, Wi-Fi 7 is a big upgrade compared to some of your older technology. Obviously, one of the big parts of that is just greater overall speed. Speeds are considerably faster now with Wi-Fi 7 than they were even with Wi-Fi 6E. Um, but also Wi-Fi 7 is building on top of Wi-Fi 6 and 6E to continue building on the idea of being able to have more users per access point and to be able to have more access points in the same area before you start running into interference issues. So some of the big things here that made the difference here is we've got even larger channels than we've had in the past. On the 6 gigahertz radio, we can go up to 320 megahertz. On the 5 gigahertz radio, we can go up to 240 megahertz wide channels. And we've added a new technology called multi-RU puncturing. So one of the challenges we've had, even with Wi-Fi 6 and 6E, if you're using these big channels, if there's any interference anywhere on that big channel, it interferes with all of the data being sent. So with multi-RU puncturing now, your access point can detect that there is overlap or interference on parts of that big channel and simply skip over those sections of the channel, allowing you to continue to use a very wide channel without having to worry about the interference issues. The other big technology we have here is multi-link operation, MLU. So traditionally up through Wi-Fi 6, um, you have access points that are broadcasting on multiple radios, but your client device can only connect to and communicate with one of those radios. So with multi-link operation now, compatible clients can simultaneously connect to two, or in some cases even three radios at the same time and use them simultaneously, spreading the data out across the different radios. So that gives you more bandwidth, it gets you lower latency, and it allows you to dynamically deal with interference issues, which may be affecting one or more of those radios. So a big part of Wi-Fi 7 is support for the 6 gigahertz spectrum. So 6 gigahertz traditionally has required a license in order to be able to use it. And so just a few years ago, the FCC decided to open this up for unlicensed usage. Um, so the big benefit of 6 gigahertz is it is a massive amount of spectrum, particularly here in the United States. So 6 gigahertz has more spectrum available than 2.4 and 5 gigahertz combined. What this means is you can have a lot more devices broadcasting at the same time before you run into overlap issues. So as an example here, with 160 megahertz channels, there was only two total available in the 5 gigahertz spectrum, both of which overlap DFS. So because it required DFS be used, that means a lot of client devices couldn't support it. But the other challenge is that even if your client devices supported it with only two channels available, as soon as you added a third access point, you would run into interference issues. So with 6 gigahertz and Wi-Fi 7 now, you've got seven non-overlapping 160 megahertz channels, where you've got three 320 megahertz channels that you can use. So it allows you to use these bigger channels without having to worry about interference with other access points, making site planning and stuff go way more easier for you. So that's it as far as just sort of the high level overview of the technology in Wi-Fi 7. So now we'll start talking a little bit about our access points. So we'll start by talking here with some of the big brushes, and that is that all of our Wi-Fi 7 access points follow our RF first by design philosophy. And what that means is when you compare us to our competition, we have more EMI shielding on the board. We built in filtering to filter out interfering 4G, or excuse me, not 4G, 4G LTE and 5G interference from nearby channels. Not a big difference. Oh, whoops, we got something coming in. Let me see what we've got here. Robin is asking about sharing these slides. Um, so this actual presentation will be uploaded to our YouTube, generally probably by tomorrow afternoon. If you need copies of the slides in PDF format, you can reach out to your salesperson, Andy, David, or Jacob, and they can get those and provide those for you. So continuing on here, RF first by design. So a lot of people don't realize 4G and 5G oftentimes are using channels that border Wi-Fi. And in cases of large buildings where they're using a DAS system to rebroadcast 4G or 5G inside the building, often using the same drops that you use for your Wi-Fi, it can cause interference issues. So we have that extra filtering built in. Another thing we do on most of our APs is we do not mount our antennas directly onto the same PCBA as the rest of the components. We are one of the only vendors that isolates them and puts them on their own board to create that greater isolation to help with those edge case issues. The other thing we do isn't really RF first by design, but it's how we build our products and we design them to last. And that's why, our cheap $120 Wi-Fi 7 access point can offer a lifetime warranty, where most of our competition in that price category are offering only a 1 or 2 year. And so the reasons for that is, one, we don't use any electrolytic capacitors. We only use solid state capacitors. So you don't have to worry about the electrolytic capacitor failing. The other thing we do is we put a lot of engineering into the ability of our APs to dissipate heat. So a very common cause of failure on solid state components is heat fatigue over time. So we usually have some forms of heat shielding or heat sinking that's designed to pull heat off of the board and then vents to allow the heat off. Where when you look at some of our competitors in the same lower end price space, not only is there no heat sinks, there are no vent holes allowing the heat to come out. So that causes heat to build up in the device and leads to premature failure, which is why they have to offer the shorter warranties. All of our Wi-Fi 7 access points use our current generation mounting bracket or some variation of it. So this is a mounting bracket that's designed, as you can see here, to be mounted directly to a ceiling, screwed directly into a wall, and has also been designed to be able to reuse the screw holes in an outlet box in both round and rectangular junction boxes. It can also be paired with our drop ceiling clips here, these T-bar clips, which you basically buy these, you attach these to your metal T-bar, which holds up your drop ceiling, and then the mounting bracket itself attaches to those, making it very easy to mount them without needing to drill any screws in your drop ceiling. And then the access point just snaps into place onto the mounting bracket. And then all of the access points we're talking about today work with Nebula. So Nebula is our free cloud managed single pane of glass management platform, which allows you to manage all of your Zyxel devices, all of your customers, all of their sites through a single pane of glass just by going to nebula.zyxel.com. So one of the first things you will notice is we have two different series of Wi-Fi 7 access points. We have the NWA series, or our N series access points, and the WBE series, which is our W series access points. So one of the first things you need to understand is, what is the difference between these two? Because if you look at the spec sheet, you will find very similar models in both the N and the W series. So the main difference here is on the software side of things. So the W series access points are Nebula Flex Pro, where the N series are Nebula Flex. And all that means is you get a 1-year Nebula Pro pack bundled with the W series access points. So if you're planning to use Nebula for management and you're planning to use Pro Pack for the extra features, such as the enhanced log retention or the artificial intelligent troubleshooting, it may just be easier to buy the W series, use that bundled license, which automatically gets applied in Nebula, rather than needing to buy the licenses and then apply and distribute them manually. The other differences here are the W series supports our local controller. I know there's a lot of you out there, or maybe that don't like to use the cloud, or your customers don't want to use the cloud. So we do support local management via a local controller, and that requires the W series in order to be able to support that. The W series also is where our advanced antenna technology kicks in. So we have what are called dual optimized antennas or smart antenna access points, and you will find those in the W series. You will not find those in the N series. Some of the other features here that the W series offers that the N series doesn't is secure Wi-Fi, the ability to buy a access point and essentially turn it into a cloud managed remote VPN appliance to make it easy for your remote users to be able to connect back to the corporate office without needing to worry about software and certificates and things like that. It supports collaborative detection and response, basically the ability for the access point to coordinate with our USG Flex Series security gateways to provide enhanced protection for wireless users getting onto your local area network. And it also supports things like GRE tunneling over IPsec. So you can take your wireless users, GRE tunnel them back to your gateway before you allow them out onto the local network. So the other thing you will see is some of our access points are labeled band flex. So I did want to talk about what is band flex and why you may or may not want a band flex AP. So as mentioned earlier, one of the big changes with Wi-Fi 7 and 6E was support for 6 gigahertz RF spectrum. So this allows access points to support up to 3 radios simultaneously, 2.4, 5 gigahertz, and 6 gigahertz. However, there are some challenges when it comes to using 6 gigahertz and tri-radio support at the same time. So one of those challenges is if you have 3 radios, you have to aggregate and manage 3 radios worth of bandwidth. So because of that, not only do you need to buy a third radio and add a third set of antennas, you also need a processor that's able to support and handle that level of throughput. So generally that increases the cost of the access point. The other challenge you run into is a lot of these tri-band, tri-radio access points require a lot of power in order to be able to operate and support that. And so because of that, many of these access points require 802.3 BTPoE, where probably your existing infrastructure on the switches only supports 802.3 AT, 30 watt PoE, where a lot of these access points will require 60 watt PoE. So what BandFlex gives us here is it allows us to reduce the cost and the capital outlay and still offer Wi-Fi 7. So Wi-Fi 7, unlike 11AC, does increase performance on the 2.4 radio, as well as the 5 and 6 gigahertz radios. So what we do here is we give you a tri-band access point, meaning it can support all 3 bands. That's only dual radio. So it can support 2.4. And then the second radio supports either supports either 5 gigahertz or 6 gigahertz as you select it. So that allows us to have a less expensive access point. It allows us to operate on existing PoE infrastructure, so you don't need to replace your PoE switches, so it keeps the cost down there. And then the other thing is right now there aren't a lot of devices that support 6 gigahertz. So you probably have a lot more users that use 5 gigahertz than use 6. So it allows you to deploy Wi-Fi 7 and get the speed increases on 2.4 and 5 today. And then later, when more devices support 6 gigahertz, you can always switch off the 5 gigahertz radio and switch it over to 6 gigahertz for those 6 gigahertz users. So you can get the benefits of Wi-Fi 7 on 2.4 and 5 today. You get a lot lower cost, both in the cost of the access point and also the not needing to upgrade your switch infrastructure. So it's a good option for those of you that don't need tri-radio operating today. So basically, again, the main thing here is it reduces your costs for you and makes it so you're future-proofing your networks that you're deploying today with support for 6 gigahertz when it becomes a lot more widespread. So now we'll start talking about the access points themselves. So again, we're talking about band flex. So these are all going to be tri-band but dual radio. So the first one here is the NWA 110BE slash WBE 510D. So these both offer wireless speeds of up to 6.5 gigabits per second by offering 4x4 support on the spatial streams, but only two of those at a time. So that is something to talk about here because this is kind of new for us. This is something that primarily Cisco has been doing up to this point. So when we're looking at the speeds of our access points, we'd often use what are called the spatial streams, how many spatial streams a device can support. And usually it was pretty simple. If it said 2x2, it supported two spatial streams. If it said 4x4, it supported four. So with these models here, we support 4x4 with :2. So what does that mean? What that means is we can support up to four spatial streams, but only use two of those at the same time. So it gives us the flexibility of selecting from four different antennas and choosing the two that are offering the best coverage or performance at that time. Um, so in reality, it's more like a 2x2 as far as performance goes, but it is a 4x4 :2. And that provides speeds up to 6.5 gigabits per second. It does support multi-link operation. And of course, it has our, RF first technology built into it. So these models here have a single 2.5 gig uplink port that supports PoE. And it is 802.3 AT-PoE or standard 30-watt PoE. Alternately, these can be powered using a USB-C PD power source. So the same sort of USB plug that you would use to charge your cellular phone can also be used to power these access points. So you might notice here that this has a D on the W version here, so WBE 510D. So what that means is the W version here includes our dual optimized antennas. So let me explain that really quick. So most access points have a single set of antennas for each radio, and those antennas are optimized with the idea that you're going to be mounting that access point on the ceiling directly over the area to be covered, and the RF signal radiates out in what's usually an omnidirectional pattern, what we normally call an umbrella coverage or an umbrella pattern. Unfortunately, out in the real world, you oftentimes have to mount your access points on the wall where they are mounted 90 degrees from the optimal antenna pattern that's built into them. So you end up sending a lot of your RF signal up into the ceiling or down into the floor where it either gets lost or can cause interference on the access points deployed on those other floors. So our solution to this was our dual optimized antennas. We give you two sets of antennas for each radio, one that's optimized for ceiling installation, one that's optimized for wall installation. And then you can choose which one to use on a per AP basis, depending on where you have deployed those access points. So moving on from there, we are now talking about the NWA 210BE and the WBE 630S. So the primary difference between these and the ones on the previous slide, the 510 and the 110, is faster speeds, 12.3 gigabits per second on the Wi-Fi radio for wireless to wireless communication. And the way we're getting that faster speed is we're offering true 4x4 on the 5 or 6 gigahertz radio. So this would be a 4x4:4. So four sets of antennas, and you can use all four simultaneously. The other big difference on these is that we have an extra Ethernet port. So we still have that 2.5 gig uplink port with PoE. And again, these are still using 802.3 AT or PoE plus. But we also have a pass-through switch port here. So you can then run Ethernet from the AP to another device or to a port in the room. So you can daisy chain and run one less Ethernet cable to the area where you are deploying the access point. The other difference is on the W series here. So while the 510 had a D, this one has an S. So that indicates that this uses our smart antenna technology. So this is a technology that's designed to increase coverage, reduce interference, and support more simultaneous users in the area than you would normally get with a standard antenna. So in this case here, instead of having your one antenna pattern like you have on your traditional access point, or having dual in sets of antennas, this has an antenna array. So it has the ability to go through literally hundreds of different antenna patterns and choose the antenna pattern that's ideal for the current RF environment, both where the current client device is in relationship to the access point, but it also allows us to take into consideration other sources of RF interference, such as neighboring access points operating on the same channel, and choose an antenna pattern that tries to ignore that source of interference. So because of this, when you're deploying multiple smart antenna access points, you can wind up in a situation where you're able to achieve greater than 100% airtime utilization, right? So generally, 100% is the maximum theoretical airtime utilization, and you generally max out somewhere in the high 90s. So with smart antenna, you can get up to as high as 140% airtime utilization shared between your access points because they're able to operate at the same time without interfering with each other. So moving on from there, I want to talk about our tri-radio access points. So these are access points that use 3 radios simultaneously. On the lower end of things, we have our NWA 130BE and the WBE 530. So again, very similar to each other. In this case here, aggregated throughput on the wireless radios is up to 11 gigabits per second. So each radio is operating at 2 by 2, so 2 spatial streams, both transmit and receive, to get to that speed. So you may notice that our dual radio access points that we were just talking about, the 210 and the 630S, actually provide higher aggregated throughput than this guy does, even though they're only using 2 radios. And that's because the 5/6 gigahertz radio on those models is able to use 4 spatial streams at the same time. So why don't we support 4 spatial streams here? Because this is the maximum performance with 3 radios we can get and still operate on standard 802.3 AT PoE plus PoE. Anything more than that is going to require 802.3 BT, which probably requires new switches for you. Now, I will say here, this is sort of pushing the maximum power output that 802.3 AT can support. So on very long Ethernet runs or runs where the cables have maybe been damaged or degraded, you may find that this isn't able to operate at full speed because of that, because basically the PoE draw voltage is dropping too much. As long as it's good new cables, good new switches, you should be fine up to the full 100 meters. But there are going to be some cases where you're using older cables where they've been damaged, where you may not be able to operate using these because of that. And like the other model we were just talking about here, the the 210 and the 630, this has dual Ethernet ports, a 2.5 gig uplink port and a 2.5 gig pass-through port. Now, one thing to notice on this model here, it does not support USB for power. So if you want to power it without PoE, you would need to use a standard AC adapter to power it instead. And then the final model to talk about today, whoops, is the WBE 660S. So this is our flagship access point. It is operating here on speeds of aggregated wireless speeds of up to greater than 20 gigabits per second. I believe it's 22 gigabits per second aggregated speeds. So extremely fast, providing 4x4 on all 3 radios. And so again, because of this and because of the greater speeds and power required, it will not work with standard PoE plus. You must upgrade your switches to PoE plus plus or add in PoE injectors which support 60-watt PoE plus plus. The other alternative here for you for powering this up again is to use a USB-C PD power brick, and that can also power this guy up here. Now, one of the things you will notice that makes this different than all of the other Wi-Fi 7 access points is this guy here has a metal back on the housing with fins here to help basically turn that back housing into a heat sink to help pull that heat off the main board because of just how power intensive this guy is and how much throughput it's got to be able to process. Um, The other thing that this guy has in it that's a little bit different is this has Bluetooth, BLE built in for BLE beacon technologies. For those of you making interactive applications that use Bluetooth, this does support that. And then another change here is the Ethernet port going into this is a 10 gig Ethernet port to help support those faster speeds. So we do have a question here coming in from RW Sanders asking, are there any wall-jack Wi-Fi 7 access points anytime soon? And the answer to that is no. At the moment, there are currently no plans for a Wi-Fi 7 wall plate in the near future that we can talk about. So one thing I wanted to highlight here for you when it comes to, why use us for Wi-Fi 7, one of the reasons here is because we are an alpha partner with Qualcomm. So Wi-Fi 7 is still in the early stages of things being standardized. Um, and because we're an alpha partner, that means we get the best and latest drivers and firmware from the chipset vendor Qualcomm themselves. And this is important because things are changing. So for instance, one change that's taking place right now that's going to happen with the July firmware update is the Wi-Fi Alliance has decided that MLO, multi-link operation, is mandatory for Wi-Fi 7 certification. So starting in July, if you enable Wi-Fi 7 on your access points, MLO will be automatically turned on. And if you want to turn off MLO, you have to go back to Wi-Fi 6 mode. Um, and again, that's not something we want to do. That is something the Wi-Fi Alliance is doing. In addition, they are making the use of WPA3 mandatory for Wi-Fi 7, which breaks dynamic pre-shared key. So if you're using dynamic pre-shared key, your access point will automatically put itself into Wi-Fi 6 mode because going forward, only Wi-Fi 6 mode will support WPA2. And again, dynamic pre-shared key by definition will not work with WPA3 on Wi-Fi 7, which is now mandatory. So that's one of the reasons why it's beneficial to work with the chipset vendor and be the first out there. There are also a lot of different implementations on MLO and various different things with what features are supported by different implementations. So again, it's another reason why it's a good idea, to be able to have access to the latest and greatest from the chipset vendor. So here is a list of all of the Wi-Fi 7 access points we have talked about today, just kind of showing you the differences on them. Not a lot here. So we did have that question from RW asking about, wall plate AP, so nothing to talk about currently. Another common question we get is, what about outdoor Wi-Fi 7? You may have noticed there are no outdoor Wi-Fi 7 access points on this slide. So why is that? So it goes back to the 6 gigahertz radio and 6 gigahertz being a licensed spectrum. So when the FCC decided to open this up for unlicensed use, it did not get rid of the licensed users. There are still a lot of users out there that have paid to use 6 gigahertz. Now, the good news in this particular scenario about 6 gigahertz is RF frequency increases, range goes down, or the more easily the signal is able to be absorbed by obstructions in the environment. So the FCC isn't that worried about 6 gigahertz use indoors, interfering with licensed users, most of which are going to be outdoor licensed users, because the signal isn't going to penetrate that far or go that far outside the building where you've deployed it. Obviously, though, if you're deploying 6 gigahertz outdoors, you now have to worry about those users interfering with the licensed users who get preference. So the FCC came up with two solutions to solve the interference issue. The first one is to limit Wi-Fi 7 or 6 gigahertz radios when used outdoors to extremely low power. And realistically, power that's too low to be, widely used for most applications. So we don't have a ultra low power Wi-Fi 7 radio for that reason. For those wanting to use more traditional power output, what the FCC has regulated is that we have to use a ACS vendor, basically a third party who tracks all licensed 6 gigahertz users and then coordinates with your access point um, to let it know which channels and what power it can use based on the physical location of that outdoor access point. So it requires your access point have the ability to determine its physical location, and your access point has to be able to communicate with a third-party service which tracks the licensed users and then coordinate with it to determine what channels and what power output it can use. Um, so that technology is still pretty early. There are vendors and solutions out there that do offer 6 gigahertz outdoor, but we have been taking our time with that, waiting for this market to sort of mature. So we will not have outdoor Wi-Fi 7 access points probably until Q1 next year. Obviously, this is a roadmap and things can change, but that's the current plan. We will not have outdoor Wi-Fi 7 until Q1 to allow the ACS market to mature and to become more standardized over time. And with that, guys, that is the end of today's presentation. So again, this has been recorded. It will be uploaded to our YouTube channel, which is Zyxel America channel. So almost all of our webinars are recorded and uploaded there. Again, it's normally about a 24 to 36 hour delay between when the webinar is done and when we upload it there. But we also have product announcement videos, case study videos, success story videos, all sorts of other stuff that gets uploaded there. So it is worthwhile to, visit the channel, subscribe to it so you can keep track of it. And then, of course, if you're on LinkedIn, feel free to reach out to us, connect to us as Zyxel US channel there. So far, there have not been any more questions coming in. So I'm going to go ahead and end today's webinar. If you do have a question, you can always email me directly, Sean R. at Zyxel.com, with Sean spelled SHAWN. Or you can always reach out to your sales guy, Andy, Jacob, or David, and they can get you those answers. Thank you for joining us today. I hope to see you at one of our future webinars.